Hi everyone, and welcome back to this video. We're going to look at the chain rule. So before we look at the chain rule, we need to talk about composite functions. And if you'll recall, the composite function, or composition, sometimes it's known as, of g and f, which are just two functions, is the function whose values are given by g of f of x for all x in the domain of f, such that f of x is in the domain of g. So we read this as g of f of x. Sometimes it can also be written as g and then the composed with symbol, which it looks like a little o, and then f of x. Viewing complex functions as combinations of simpler functions, which is really what composition of functions are, makes them easier to understand and use, which is why we're going to be quickly reviewing composition of functions, which is something that was covered in an algebra course at some point. Let's look at an example of composition of functions. So let f of x equal 2x minus 1 and g of x equals the square root of 3x plus 5. And let's say I want to find g of f of 4. So the first thing I need to do is I'm going to work inner to outer. Okay, I'm going to find f of 4 first, and we know that that's just an evaluation problem. So I'm just going to simply find the f function, and I'm going to substitute 4 in for x. So the f function is just 2x minus 1, and when I simplify that, I get 7. So what I just found was that f of 4 equals 7. So I'm going to replace f of 4 with 7 now, and I'm going to find g of 7. And now I'm going to go to my g function, which is the square root of 3x plus 5. And I know that x is 7, so I'm going to have 3 times 7 plus 5, and that would give me the square root of 26, which is my final answer. Okay, let's try another one. F of g of 4. So this time I need to find g of 4 first. And the g function is the square root of 3x plus 5. So I'm just going to substitute 4 in for x. And when I do that, I get the square root of 17. So that tells me that g of 4 is the square root of 17. So I'm going to substitute the square root of 17 now into the f function. So I'm finding f of the square root of 17. And I'm just going to have 2 times the square root of 17 minus 1, which can't be simplified any further, so that would be your final answer. Here's another example of composition. So we have two different functions. F of x now is 2x squared plus 5x, and g of x is 4x plus 1. And if I want to find f of g of x, all I'm going to do is I'm going to take my f function, which is 2x squared plus 5x, and I'm going to replace all the x's with g of x, and g of x is 4x plus 1. So I'm basically finding f of 4x plus 1. So I'm just going to substitute in now into the f function 2 times the quantity 4x plus 1 squared plus 5 times 4x plus 1. And I know that 4x plus 1 squared is 16x squared plus 8x plus 1. And then I have, again, 5 times 4x plus 1. And I'll distribute through first the 2. That's a 16. And then I'm going to distribute the 5. And now combine any like terms. So I have got a 16x and a 20x, which will give me 36x. And then 2 plus 5, which is 7. So you get 32x squared plus 36x plus 7. And that would be your final answer. In letter B now, I'm substituting f of x into g. So I'm basically finding g of 2x squared plus 5x. So I'm going to substitute the 2x squared plus 5x in for x, and then you've got plus 1, and then distribute. And that would be your final, sorry, that stays plus 1. That would be your final answer. You can pause the video now and try some more problems on your own. You're going to use the functions in example 1, so this example here, to answer the questions and to check your understanding. And then you can unpause the video when you're ready to move on. There's also a check your understanding number 2 here, which you can try as well. And then you can unpause the video when you've tried. Okay, let's look at example number 3. So here, which is a very important skill for the chain rule, is write each function as the composition of two functions f and g, so that h of x equals f of g of x. So in other words, h of x is composed of f of g of x. So what I need to do is first look at the problem, and I can kind of see that the 4x plus 1 is occurring twice. So when I'm creating my function, right, that's going to be the part that's going to be your g of x, because it's what you're substituting in. It's kind of like here, if we take a look at this problem, g of x was 4x plus 1, right? And it came up 2 times in the problem. So that's the part that occurred twice, right? So that's going to be your g of x. So g of x is the piece that is occurring more than once. And then that would tell me that f of x has to be 2x squared plus 5x. Because remember, g of x is being plugged inside f. So this is going to go in here. And if you do that, you end up with that. Right? So there's essentially your answer. So therefore, h of x is just going to be f of g of x, which would just be 2 times 4x plus 1 squared plus 5 times 4x plus 1. Feel free to pause the video and try the next problem, and then you can unpause when you're ready to move on. So now we're ready for the chain rule, which is an important rule in calculus. It comes up quite frequently, and a lot of times we use it in conjunction with the power rule. So the chain rule basically just says if y is a function of, let's say, u, okay? So in other words, y would equal f of u. And let's say u is a function of x. Okay, so let's just say u then would equal, we'll call it g of x. Okay, then that tells me y is equal to f of u, which is equal to f of g of x. And the derivative of y with respect to x would just be the derivative of y with respect to u times the derivative of u with respect to x. So in other words, what we're going to do first is we're going to find the derivative of y equals f of u. Step 2 is we're going to multiply the result by the derivative of u equals g of x, and then replace each u back with the g of x. Here's an example. So we want to find the derivative of y with respect to x if y equals quantity 3x squared minus 5x to the 1/2 power. Okay, so here's one way we can do this. So the first thing we're going to do is let y equal f of u. Okay, and what would our function be here? This part is going to be the u. So it's just u to the 1/2 power. Okay, then we're going to let u equal g of x, that actual function. So we've got 3x squared minus 5x. That's really what u is equal to. Okay, so in other words, here's your outer layer. Here's your inner layer. Kind of like in these problems here. Here was your outer layer. Here's your inner. Okay, so then y would equal f of g of x, which is just going to be 3x squared minus 5x to the 1/2, right? I'm placing g of x inside of f. Here's g of x, here's f. So then the derivative of y with respect to x is just going to be the derivative of y with respect to u times the derivative of u with respect to x. Okay, so I have everything I need now. I need the derivative of y with respect to u. Well, here's y, right? And with respect to u. The derivative of this, using my power rule, would just be 1/2 u to the negative 1/2. And then I want to find the derivative of u with respect to x. So here's u. Now I'm finding the derivative with respect to x. So again, it's like your general power rule. That would just give me 6x minus 5. So then your final answer is going to be, so the derivative of y with respect to x, I want to replace the u's with actually what it equals. So 3x squared minus 5x. So I'm going to have 1/2 times 3x squared minus 5x to the negative 1/2 power, and then times 6x minus 5. Okay, and we can take the 6x minus 5 and leave it on top, right? If we multiply those things out, we know we would have to move this piece to the bottom because it's a negative exponent. So I'm just going to place that down there, and now it turns positive. So that would be your final answer. Okay, let's try another one. So we want to use the chain rule to find the derivative of this function with respect to x. So the first thing I'm going to do is let y equal f of u. Okay, so what does that mean? Well, this is going to be my u, so it's u to the 8th would be f of u. So then we're going to let u equal g of x, which is just going to be x squared plus 5x. So that tells me y is going to be f of g of x, which is just going to be the f function, and then with g of x in place of it. Okay, so now I want to find the derivative of y with respect to x. So that's the derivative of y with respect to u times the derivative of u with respect to x. Okay, so the derivative of y with respect to u would just be 8u to the 7th. And then the derivative of u with respect to x would just be 2x plus 5. And then all I need to do now is replace the u with the actual expression, which is x squared plus 5x. And then multiply by 2x plus 5. And I can't forget about the 8. Because it was 8 times u to the 7th, right? So 8, there's your u to the 7th, and then times derivative of u with respect to x. So why don't you practice here with this next example, and then you can unpause when you're ready to look at what's called the general power rule, which is going to be quite helpful. And it will actually eliminate some of this work. So the general power rule is, now that we learned about both the power rule and the chain rule, is just both of those combined together, okay? And the general power rule basically just says if some function g of x is a function of x, and y equals g of x to the n power for any real number n, then the derivative of y with respect to x is just going to be n times g of x to the n minus 1 power. Okay, does that look familiar? So that's your power rule. And then we're going to multiply that by the derivative of g of x. Okay, so here's how we can use the general power rule and kind of bypass what we just did with the u's. So I have some function raised to the 10th power. Okay, so it's a composite function, right? Here's the inner piece, the outer would just be like u to the 10th. Okay, so what I want to do to find the derivative of y with respect to x is I'm first going to use my power rule. Okay, so what would my power rule be? Well, here's my power. So I'm going to multiply that by the coefficient in front. 10 times 1 is 10. And then I'm going to rewrite my expression here. And then it's going to be to the 10 minus 1 power. Okay, that takes care of this first part. Now I need to multiply by the derivative of g of x. Okay, well, what's g of x? G of x, remember, is the piece inside. It's the u. So that would be the derivative of 5x squared plus 3x minus 4. Okay, so if I simplify that, I just get 10 times 5x squared plus 3x minus 4 to the 9th power. And then the derivative of 5x squared plus 3x minus 4, if I just use the power rule there, I would have 10x plus 3. And then that's pretty much your answer. All right. Now you can see how you could use that with these problems as well. So if I was to go back to, let's say, this one, okay, if I wanted to use the general power rule, I would first use the power rule, right? So I would have 8 times x squared plus 5x to the 7th. And then I'm going to multiply by the derivative of g of x. So that would just be your x squared plus 5x, the inner piece. So that's just going to be 2x plus 5, right? And if you look at what you got there, it's the same thing. Okay, so let's try another one. So here we have h of x, which is the square root of 7x minus 8x squared. So the first thing I'm going to do is just rewrite that. And we know that this is just going to be 7x minus 8x squared to the 1/2 power. So now to find the derivative, I'm going to find the derivative of the first part. So that's using the power rule. So that's going to be 1/2 times 7x minus 8x squared to the negative 1/2 power. And then we're going to multiply by the derivative of the inside. And the inside would just be 7 minus 16x. And now this is just going to be some moving things around, right? So I need to take this piece and put it on the bottom to make it positive. On the top, I'm just going to have 7 minus 16x. And on the bottom, I would have 2 times the quantity 7x minus 8x squared, and then to the positive 1/2 power, which if you feel more comfortable, you can write it as 7 minus 16x over 2 times the square root of 7x minus 8x squared. So either way is correct. Okay, here's another one. So again, I want to do a rewrite here, and in order to use the chain rule. So I'm going to take the x squared minus 9 to the 5th and put it on top by making it a negative 5. Now I can use the chain rule. So I'm going to multiply the negative 5 times 7, which will give me negative 35. And then it's going to be times x squared minus 9. Negative 5 minus 1 is negative 6. And then I'm going to find the derivative of the inside. So that would just be 2x. And then I can just multiply negative 35 times 2, which would be negative 70x, and then times x squared minus 9 to the negative 6. And we can leave the negative 70 on top, and then place the x squared minus 9 to the 6th on the bottom, and that exponent would turn positive. Okay. Let's look at another one. So what do you notice about this problem compared to the other problems? This problem is made up of basically two separate pieces. You've got a 4x, and then you have this other piece, 3x plus 5 to the 5th. So think of 4x as like u, and 3x plus 5 to the 5th as v. You basically have u times v, which means you're going to have to use the product rule. And if you'll recall, the product rule is u times v prime plus v times u prime. Okay, so I'm going to have to do that first. Okay, so to find the derivative, I need to use the product rule. So I'm going to have u, which would be 4x, times v prime. Okay, so v prime, I'm going to use the general power rule, and that would just be 5 times 3x plus 5, and then to the 4th power. And then it's going to be times the derivative of the inside, right? So this is the chain rule aspect of it. So it's your power rule times the derivative of the inside, which would just be 3. Okay, and then I've got plus v, and then times u prime. And u prime is just going to be 4. Okay, so again, I'm using the product rule because I have a u times a v, but I need to, when I'm looking at the product rule, right, when I'm finding the derivative of v, v is made up of an expression to the 5th power, so I have to use the chain rule. Okay, which is what I did here. So now this is just a matter of moving some stuff around. So let's see. I can multiply 4 times 5, which is 20, times 3. So that's going to give me 60x on this side times 3x plus 5 to the fourth. And then I have plus 4 times 3x plus 5 to the fifth. Okay, now I notice they both have a 3x plus 5. And I also notice that I can factor out a 4, right? 4 goes into 60 and 4. So I'm going to pull out a 4, and I'm going to pull out 3x plus 5 to the fourth power. So I'm factoring that out, and what's left over would give me 60x divided by 4, which is 15x. And then if I factor a 3x plus 5 to the fourth out, that one goes away, and I'm left with one of them there. So I'm left with plus 3x plus 5. And then I would be left with 4 times 3x plus 5 to the fourth. And then I've got 15x plus 3x, which would give me 18x, and then plus 5. So that's my final answer. Okay, and you can try the next one, which uses the product rule and the chain rule as well. And then you can unpause the video when you're ready to do the last problem. Okay, so here's one more example, and then I'll leave the last problem, which is a revenue problem, for you to try on your own. So here we're asked to find the derivative of this expression with respect to x. Okay, and if you notice now we have a quotient here, right? So that means we're going to have to use the quotient rule along with the chain rule. And if you'll recall, the quotient rule was something like v times u prime minus u times v prime all over v squared. All right, so the u is on the top, right? And then the v is on the bottom. So we've got v times u prime. Well, u is 3x plus 2 to the seventh. I have to use the chain rule, right? So using the chain rule, which I'm going to use the general power rule, which is the power rule plus the chain rule. You have 7 times 3x plus 2 to the sixth, and then times the derivative of the inside, which would just be times 3. Okay, minus u. So u is the 3x plus 2 to the seventh, and then times the derivative of v. So the derivative of v is just 1. And then it's going to be all over v squared, so x minus 1 squared. And then I got to clean up the top. So I can see here I can multiply the 7 times the 3, which would give me the 21. So right now I have 21 times x minus 1 times 3x plus 2 to the sixth. And then I've got minus just the quantity 3x plus 2 to the seventh. And then all over x minus 1 squared. Okay. Now again, I can see that I have 3x plus 2 to the sixth and 3x plus 2 to the seventh. So we're going to factor that 3x plus 2 to the sixth out of there. There's nothing else I can factor out. So I'm going to have 3x plus 2 to the sixth. Okay, and what comes out of there would be 20, or what would be left would be 21x minus 1 minus the quantity 3x plus 2, and then all over x minus 1 squared. And then I'm going to have 3x plus 2 to the sixth times 21 times x minus 1. So actually we can distribute just to save some steps here. And then distribute. And then all over x minus 1 squared. Okay, and let me shrink this so I have some more room. Okay. And then what my final answer, if I combine like terms, I get 3x plus 2 to the sixth times, let's see, we would get 18x minus 23. And then all over x minus 1 squared. And that's it. So again, there's a application problem for you to try here. And I hope you've enjoyed this lesson. If you have any questions, please feel free to reach out to me at any time. Have a great rest of your day, everyone.